Hello everyone, myself Ayush Tripathi. Currently I am working as a mentor and a problem setter at Geeks for Geeks, and I welcome you all to this post analysis video of last weekly contest 179 and talking about the problem difficulty level. So all the problems are from easy to medium level. The last problem has prerequisite disjoint set union data structure, and for rest of the three problems there is no prerequisite at all. So let's just quickly start with the first problem, string operation. In this problem you are given a string s consisting of a lowercase English letters, and you are allowed to perform the following operation any number of time. And in one operation you can select any three identical characters, that is same characters from the string, and they do not need to be consecutive, and remove them. That is, each operation will reduce the length of the string by 3, and we need to report the minimum number of operations required to reduce the string to its smallest possible length. So let's see how we can solve this problem. So basically we have to reduce the length of the string to its smallest by using the minimum number of operation. But here, since every operation remove three characters from the string, and all the three characters should be identical, so that's why the number of operation required to reduce the string to its smallest length is constant. We cannot minimize the number of operation. Now we need identical characters. So for this thing, I will use a frequency array to store the frequency of each and every character. So for this thing, I can declare an array, let's say named as frequency of size 26, because we only have a 26 different characters, and it was mentioned in the problem statement that a string s will only contain lowercase English letters. So I will just simply map index 0 with the character a, index 1 with the character b, and so on, index 25 with the character z, and we only have these many possibilities. Cool. You can also use a map data structure, but it is not recommended because the array is faster as compared to the map. So here the frequency of character a, which is 5, and the frequency of character b, it is 3. The frequency of character d, it is 2. So in one operation, I will select three occurrences of character A and will remove them, so that its length reduced to 2. If you remove three characters, then the previous frequency of A was 5. Now the current frequency of A is 2. And since we have to select three characters, so now we cannot perform any operation for character A. Then we have character B. So I can also remove three characters from here, and so that its frequency reduced to 0. Then since here we have only two characters and we must need three characters to perform operation, so it will remain as it is. So for every character, my answer, or the number of operation we can perform, is equals to frequency of the character and dividing it by 3. Cool. And taking its floor value. So this is the complete solution. Let me just show you the implementation. So here I have declared a vector of size 26 and all the values to 0, because initially all the character has frequency 0. Then updating this frequency vector, then answer is 0. Then I iterate over all the indices from 0 to 25, and I will just simply increment my answer by frequency of character I, dividing it by 3 and taking its floor value. These many operation I can perform for character I. Cool. And finally I am returning this answer. Now let's just move to the second problem of the contest. So this is the second problem of the contest, min XOR, and it is purely greedy problem. So let's just quickly read the problem statement and discuss the solution. So in this problem, you will be given an integer array ARR of size n, and also provided an integer k and which is representing the maximum number of operation that can be performed. And in one single operation, you can pick any element of the array and unset any of its set bit, that is change 1 to 0 in binary representation of that number. And our task is to perform at most k operation to minimize the XOR value of entire array. So let's see how we can solve this problem. So let's consider this array of 5 element and the value of k is 2. That is, at max we can perform 2 operation. So here I'm going to write the binary representation of all the elements. So the binary representation of 5, which is 1 0 1 4 plus 1, and also let me write a 2 leading 0, then 1 0 and 1. Cool. Then the binary representation of 6 1 1 0. So 1 1 0 and 2 leading zeros. If it is 32 bits, then we would have remaining bits as 0. Then 11. So the binary representation of 11 is 8 plus 2 plus 1. So 1 0 1 and 1. Cool. Also let me write the weight of each bit. So 0 2 power 0, that is 1. Then the weight of the second bit is 2, that is 2 power 1, which is equals to 2. Then 2 power 2, which is 4. Then 2 power 3 8 and 2 power 4, which is 16. Cool. Then we have 17 1 16 plus 1 0 0 0. Cool. And then we have 20, which is 16 plus 4. So 1 0 1 0 and 0. Cool. And after performing at most k operation, we need to XOR all the elements. That is, the XOR of entire array must be minimum. So let's just quickly discuss the XOR property. So 1 XOR 1, which is equals to 0. 0 XOR 0, which is also equals to 0. And when the bits are opposite, that is 1 XOR 0, then it is 1 only. And if the bits are same, then it would be 0. Cool. And there is another property of XOR. You can just simply count the number of ones. If it is odd, then the bit is set in your answer, and if it is even, then the bit would be unset in your answer. So what I'm trying to say, let's consider this expression: 1 XOR 1 XOR 0 XOR 1 XOR 0 XOR 1, and let's say XOR 1. So here what you can do, you can use a traditional method, that is first take XOR of these two elements and take XOR of this result with 0, then the result of this expression, and then take XOR with 1. But this is a quite a lengthy process. So what you can do, you can just simply count the number of ones, and if the number of ones is odd, then XOR value would be set, and if the number of ones is even, then all the ones will get cancelled out. That is, you can form a pair of ones and each one will get cancelled out each other, and in the result you would get 0 if there is a even number of ones. But since here we have 5 occurrences of 1, which is odd, so that's why here the result is 1. Cool. So we all know that MSB is having the maximum weight. That is, the bit which is on its left is having the maximum weight. So what I can do, I will give the priority to the leftmost bit, and if it is a set in answer, then I will just simply change one bit from 1 bit to 0, so that if it was odd, then it will change it to even. And we all know that if we have even number of ones, then the result would be 0. Cool. So here I have a 2 set bit. So just simply iterate over all the integers from 30 to 0, because maximum we would have 30 bits. Here you can see the value of element can be up to 10 power 9. So a of I is less than 10 power 9. So I can say there will be at most 30 bits in a of I, because the 2 power 30 is greater than 10 power 9. Cool. So that's why just only iterate over the 30 bits, and from 30 to 0, that is from higher bits to the smaller bits. Cool. or you can also say from MSP to LSP in this way. And for every bit, I will just simply check whether this current bit is set or not in answer or in answer. So here we have for this bit, we have two occurrences. We have 2 1. So we all know that the result would be always 0. Because if you have a 2 occurrence of 1, then each occurrence will cancel out each other and the result would be 0. So I'm not going to perform any operation for this bit. Then I will just simply check for the next bit. So the next bit, which is bit 3. So here you can say bit 0, 2 power 0, which is 1, then bit 1, then bit 2, 2 power 2, 4, then bit 3, and bit 4. So up to 30. Cool. So for bit 4, we have a 2 set bit, and each set bit will get cancel out each other. So the result would be 0. And happy case, then next bit, which is 3. So here in this case, we have only one set bit. So the result is 1. But since I am left with some operation, so what I can do, I can just simply perform one operation and on element 11 and change this bit from 1 to 0. I will just simply change this bit from 1 to 0. Cool. And since previously we have odd number of ones, and since I have deleted one occurrence of 1, so the result, now we are left with even number of ones. And if we have even number of 1, then the result is 0. So an happy case. Cool. And now we are left with only one operation. And basically this is the best time to perform the operation. Then for the next bit, which is bit 2, and its bit is 4. So here we have a 3 occurrence of 1, that is 3 set bit. So we can pick any element and perform the operation. So let's just quickly consider this element 5. So just simply change this set bit to one set. Cool. And now the number of operations reduced to 0. And it does not have contribution because previously it was odd. Now it has changed to even. The frequency of 1 has changed to even. And if we have even number of ones, then the bit would be 0 in the result. So this is 0. Then the next bit, which is 1. And here we have a frequency of 1 as even. So the result is always 0. Then here in this case, here we have 3 occurrences of 1. And since we are not left with any operation, so its contribution will be in the answer. This is my answer. Binary representation of my answer. So here we have 3 occurrences of 1. And since we are not left with any operations, so cannot perform any operation, so we must have this bit as set in my answer. Cool. And this is the complete explanation. Just simply iterate over the 30 bits from I is equals to 30 to 1 to 0, not 1. And for every bit, just simply check how many elements have this ith bit set. And if it is odd and you are left with some operation, then perform one operation in any element. And if it is even, just simply skip the bit because the result is 0 for this particular bit. So let me just show you the implementation. So here I am having my answer variable and initializing this answer with 0 and then integer I, then I is equals to 30 to 0 and I minus minus. Then here we have a variable count which has been initialized with 0 that will simply store the number of element which has this ith bit set. Then I iterate over all the elements of the array. And here I am just simply checking whether this bit is set or not. And if this bit is set, then just simply increment the value of count. And then I'm checking if the count is odd, that is we have an odd number of ones, then we have to perform some operation. And if we are left with some operation, then I will just simply perform one operation in any one of these bit. And otherwise this bit would be set in my answer. So that's why I am just simply taking XOR, basically marking this bit, this ith bit set in my answer. And finally I am returning this answer. And this is the minimum answer that we have. Minimum XOR of this entire array. So the time complexity, which is 30 into n, the time complexity is n into 30. Cool. So now let's just quickly discuss the third problem of the contest. So this is the third problem of the contest, possible split. In this problem, you are given an array of size n, and your task is to determine if it is possible to split the array at some index I such that product of the elements in the left sub array, which is starting from index 0 to I minus 1, has the same number of trailing 0 as the product of elements in the right sub array, which starts from index I and goes till last index, which is n minus 1. And we have to return 1 or 0. If it is possible, then return 1, otherwise return 0. Cool. So for the first example, we can split this array from index 2. And so in the left subarray, we would have 2, 5 and its product is 10. And in the right subarray, we would have 1, 10 and their product is also 10. So both has 1 trailing 0. So that's why here the expected output is 1. So let's see how we can solve this problem. So let's just first analyze how we get a trailing 0. So let's say you have some number. Let's say it is 13. And to get a trailing 0, we must have to multiply this number by 10. So to multiply by 10, you would get 130, which has 1 trailing 0. And if you again multiply it by 10, then you will again get 1 trailing 0. So it is 1300. But considering 10 is not the correct solution at all, because consider this case, it would fail for some test cases. Consider this case 2, 5. So here 2 does not have trailing 0, 5 does not have trailing 0, but their product have 1 trailing 0. So 2 multiplied by 5, which is equals to 10, and it has 1 trailing 0. So what I'm trying to say, we have to consider the smallest possible unit. That is, instead of considering this 10, consider the smallest possible unit, that is the prime factorization of 10. So I can write it this way. Instead of writing 10, its prime factorization, which is 2 multiplied by 5, and every pair of 2, 5 will give you 1 trailing 0, and this is the correct solution. Cool. So let's say you have a number 12, and if you multiply this number 12 with 2 and 5, that is one pair of 2, 5, then it will give you 1 trailing 0, which is 120, and it has 1 trailing 0. And if I again multiply this with another pair of 2 and 5, then you would get again another 0, that is a 1200. Cool. So let's say we have some array A, and if it is possible to split this array at some index I, such that the number of 2 and 5 is same as the right subarray. So in this case, if we have a same occurrence of 2, that is, let's say count 2, if we have same count 2 and same count 5, and here also let's say we have a count 2 occurrences of 2 in prime factorization of all the numbers, and count 5 occurrences of 5 in the prime factorization of all the numbers, and if both the values are same, then I can say I will split the array at index I, and the left subarray has the same number of trailing zeros as in the right subarray. Cool. And how do we find this count 2 and count 5 value? So let's say you have a number 600. So we need to count the number of 2's and the number of 5 in its prime factorization. So let me just quickly write its prime factorization. So it is a 2 multiplied by 2 and multiplied by 5, which is 100 multiplied by 3. So 300 and multiplied by 2. So which is 600. Cool. So how many pairs of 2, 5 we have? So here we have 2 pairs of 2, 5. This is one pair, and this is another pair. And every pair will give you 1 trailing 0. So that's why here we have 2 trailing 0. Cool. So to find this thing, I can simply initialize my count 2 variable with 0, which will simply store the number of 2's in the prime factorization of current number. Then the pseudocode would be while num mod 2 is equal to 0, and if the remainder is 0, then it means it does have 2 in its prime factorization. So I can just simply increment the value of count 2 plus and divide this number by 2, that is, remove one occurrence of 2. So num is equals to num divided by 2. So for this example 600, first I will remove this 2, then this 2, and then finally this 2, and after this the number is no more divisible by 2, so this while loop will get terminated. And similarly I will check for 5, that is let's say count 5, which is equals to 0, and it will simply store the number of occurrences of 5 in its prime factorization. So I can use the same logic while num mod 5 is equal to 0, increment the value since we got one occurrence of 5 in its prime factorization, and remove this 5. So update num with num divided by 5. So in this way, we can find count 2 and count 5 values. And to get in a prefix, I can just simply use the prefix and suffix logic. That is, first I will pre-compute for every suffix, and then I will just iterate from left to right. And for every index I know the occurrences of 2 and 5 in a prefix, and I can easily get the occurrences of 2 and 5 from the suffix in my pre-computed array. So in my implementation, I have used an array of pairs. You can also use a 2D array in case if you are using Java, since Java does not have a pair container. So yeah, then suffix of I will simply store the number of 2's and the number of 5's in prime factorization of all the numbers in the subarray starting from index I to index n minus 1. Cool. And for the current integer, I will use this logic to compute the number of 2's in the current integer and the number of 5, and then I will just simply add the result of the previous suffix. So what I'm trying to say, so let's say this is index I. So if you want to count the number of 2's and number of 5 from index I to n minus 1, and if you already know the result from index I plus 1 to n minus 1, then you can just simply add the current occurrence of 2 and 5 in the previous prefix. Cool. So this is very straightforward and very standard technique of a prefix and suffix sum. So yeah, this is the complete implementation, complete approach. Let me just show you the implementation here. So here I am having my get method to get the number of 2's and the number of 5 in a prime factorization of n. So this is count 1, which will simply store the number of 2's in a prime factorization of n. And here I am using the same logic. And this loop will run at max log of n base 2 time, because every time we are dividing the number by 2. And then we have a count 2 variable that will store the number of 5 in a prime factorization of n. And using the same logic, and this while loop will run at max log of n base 5 time, because every time we are dividing the number by 5. Cool. And finally I'm returning this count 1 and count 2 values. Then this is the method that we have to complete with the parameters n, size of the array, and the original array. Cool. Then here I am having my suffix vector, which is of a pair. And in case if you are using Java, then you can go with 2D array. So for the last index, we have only last element. So that's why this is my base case. Then I iterate over all the indices from n minus 2 and up to 1. We don't have to iterate up to 0, because we must have the left subarray must not be empty. Then this is the current occurrence. This is the current pair, that is number of 2's and number of 5's in the current element ARR of I. And I will just simply call this method get, and it will return me a pair that is named as P here. And this is Q, which is simply in the previous suffix, which is from I plus 1 to n minus 1. And then I will just compute the answer for the current suffix from I to n minus 1. So this is my previous occurrence of 2 and previous occurrence of 5. And in this previous occurrence of 2, I will add the current number of 2's in the current element ARR of I, and the current occurrence of 5 in the element ARR of I. Cool. In this way, I will just simply compute this suffix array. And then here I am having a pair for a prefix. You don't have to create a specific specific another array for a prefix since we are moving from left to right. So meanwhile we can compute this prefix part. Then iterate over all the indices from 0 to n minus 2 because the right subarray must be non-empty. And this is the current occurrence of 2s and 5 in the element AR of I, which is stored in a pair X. And in the previous prefix, I will just simply add the current occurrence of 2 and the current occurrence of 5. And then here I am having a variable P, which is simply equals to minimum of a prefix dot first and comma prefix dot second. Cool. And then similarly here I am finding for finding minimum for this suffix part, and if this minimum is same, then I will just simply return 1. Cool. Because there might be the case when in the suffix you have 3 occurrences of 2 and 2 occurrences of 5, and in the prefix let's say you have 4 occurrences of 2 and only 1 occurrence of 5. So how many pairs we can form? So we can just simply form only one pair. So this is one pair, that is it has one trailing 0, and it also has one trailing 0. Cool, because it has basically a 2 trailing 0 because here we have 2 pairs. This is 2 comma 5 and this is another 2 comma 5, and that's why I have taken the minimum from both the sides. The minimum number of the number of trailing 0 we would have. So this P will simply store the number of trailing 0 in the left subarray, and this Q will store the number of trailing 0 in the right subarray. And if both are same, then I will just simply return 1. Otherwise, after considering all the indices, I will simply return 0, that it is not possible to split the array. Cool. So let's just try to submit this. So successfully submitted, and the time complexity is n because of this for loop, and the log of n base 2, because in the worst case AR of I would have all its factor as 2. So in that case the while loop will run maximum number of time, which is log of AR of I base 2. Cool. And here the value of AR of I can be up to 10 power 9. So in the worst case, let me just quickly write the time complexity. So the time complexity in the worst case is n, then log of 10 power 9 and base 2. Cool. So this is the complete solution for the third problem. Now let's just quickly discuss the last problem of the contest. So this is the last problem of the contest, equal islands. In this problem, you are given n islands, each with an importance value represented by an array ARR of size n, and here one base indexing has been considered. The importance value of ith island is given by ARR of I, and you are also given Q queries where each query merge two distinct island into a single larger island. The importance value of a newly formed island after merge will be the sum of the importance value of the two merged island. And after performing all the Q queries, it is guaranteed that the total number of remaining distinct island would be less than or equal to 150. This is very important information. And here your task is to determine whether it is possible to split these remaining distinct island into two non-empty groups such that the total importance value of one group is equals to the total importance value of other group. So before solving this problem, let's just quickly analyze the constraint. The value of n can be up to 10 power 5. The number of queries can also be up to 10 power 5. And after performing all the Q queries, the number of distinct island would be less than or equal to 150. Cool. And the sum of this entire array is also less than or equal to 10 power 5. So the prerequisite for this problem is a disjoint set union data structure. So make sure to read about some article or watch some video for this data structure. So let me just quickly explain you the approach. And so what I can do, I can just simply merge the indices with the help of this disjoint set union data structure. And also I will store the sum of node values in the leader element. That is, let me just quickly explain you the approach. So let me also write the indices here. So here I am considering the one base indexing as per my implementation, but you can also go with the zero base indexing by just subtracting one from these queries. So index 1, 2, 3, 4 and 5. So we all know that if we initialize our DSU, then initially all these set are independent, are separated from each other. So here I'm also writing the index. This is index and the value of this index. So 1 comma 1, and it is separated from every other index, or you can say island. Then we have a 2 comma 2, then a 3 comma 3, then 4 comma 4 and 5 comma 5, that is index 5 and value 5. And now please try to pay more attention. I will also store the sum of node values at every leader element. So the first query where I have to merge the island with the index 1 and 2. So let's just quickly merge index 1 and 2. So this is index 1, and let's say index 1 is a leader element of this disjoint union. So 2 comma 2, and also I will store the sum of node values in the leader element. That is here I will just simply add it 2. So now it is equals to 3. Cool. Then the next query, which is 2 comma 3, that is merge index 2 and merge index 3. So I will just simply add this 3 comma 3 here in this larger island. So 3 comma 3, and also I will add its value, which is the 3, in the leader element. So 3 plus 3, which is equals to 6. Cool. And then we have a third query, 4 comma 5. So here I guess I forgot to write one more value. So in the test cases, in the given sample input, there are 6 values from 1 to 6. So let me also write value 6, and its index is 6. Cool. So the next query where we have to merge index 4 and index 5. So initially 6 comma 6, that is index 6 is independent. So then I will merge index 4 and index 5. So simply merge index 4 and index 5. So 5 comma 5, and let's say this 4 is a leader element. So I will just simply add the value of rest of the nodes. So which is 4 plus 5, which is equals to 9. So this is an underlying structure of a disjoint set union after performing all the Q queries. So what are the values we have? So we have this island. We have this island with the total value as 6, which is stored in a leader element. And then we have another island with the total value 9. And then finally we have this island with the total value 6. So let me write these values. So here we have 6, then we have 9, and then we have again we have 6. Cool. So let's just store these values in some temporary array. Let's call this array as auxiliary array. So these are the value, and now can I say this thing? I need to check whether there exists some subset, that is some non-empty group with the total value as a total sum of this array dividing by 2. So here what will be the sum, total sum? It is simply equals to 6 plus 9 plus 6, which is equals to 21. So we have these many elements in this auxiliary array. I need to select some subset with the total value as a total sum of this array dividing it by 2, because this is the problem statement. And here I have to check one condition. If this total sum is not divisible by 2, then it is not possible. It is not possible to divide the remaining islands into two non-empty group with the same sum, with the equal sum. So here is my edge case. Here is an edge case, that is if this sum mod 2 not equals to 0, that is it is not possible to divide, then I can simply say it is not possible and I will return 0. Cool. And let's say it is possible. That is, let me just add one more element. That is, there is one more island. Let's say with the index 7 and with the value 3, and it is also separated initially, and we didn't get any query to merge this island with the index 7 and value 3. So this is separated from every other index, every other island. So here I will just simply write this value 3. Now we have 4 elements in this auxiliary array. Now again the problem is same. I need to select some subset with the total value as this sum divided by 2. So here the value of sum is equals to 24. Yeah, value of sum is equals to 24, and we all know it is possible. That is, I will just simply select this 9 and this 3, which is 12, and the remaining subset is also having sum 12. So in such case I have to return 1. That is, it is possible to split the remaining islands into two non-empty groups with the same value. So this is a very standard problem of our dynamic programming, but let me just first write the requirement, what we need to check. So now I need to check if there exists some subset with the total value as sum dividing by 2. Cool. And this is a very standard problem of our dynamic programming. It's actually a subset sum dp. So let's just define a state, and also let's just write the transitions. So let's say dp of I j will simply represent whether there exists some subset in the subarray from index 0 to I with the sum equals to j or not. This is a very standard problem. So whether there exists some subset in a subarray from index 0 to index I with the sum, or we can say with the total value as j. And so what will be my answer? My answer is simply equals to dp of n comma sum divided by 2. So my answer is simply equals to dp of n. That is, we have to consider this entire array if in this entire auxiliary array. So do not get confused. That is, here this here I am just taking this n as the size of this auxiliary array. So here n is the size of this auxiliary array. Cool. So dp of n and comma sum dividing by 2. If in this entire array there exists some subset whose total value is equals to sum dividing by 2, then the remaining elements of the array would definitely have the total as a sum by 2. So I can say we can split them into two non-empty groups with the same total value. And what will be the transition? For every index I have two options, that is either include the index in the subset or do not include it. So dp of I j, it is simply equals to dp of I minus 1 and j. So this is basically an exclusion part where I do not include the element at index I. So I will just simply say, tell me whether from the previous subarray 0 to I minus 1 it is possible to form a sum j, and if it is possible, then I can also say it is also possible from the subarray from 0 to I, because we just only need to check whether there exists a subset or not. Or dp of I minus 1 and j minus a of I. So if from the previous subarray, that is from 0 to I minus 1, if it is possible to make this sum, then I will just simply add a of I, and so I can say from the entire subarray 0 to I, it is possible to form a sum j. Here if you add a of I, then it will just simply equals to j. Cool. So yeah, this is the transition. And what would be my base case? So my base case, that is from an empty subarray, it is only possible to make a sum 0. That is a dp of 0 comma 0, it is equals to 1. Cool. And here I have just use index 0 for empty subarray. In case if you have written the top down approach, then you don't have to use this index 0 as an empty subarray, because we can write a separate base cases at the top of the recursive function. But since this is a bottom up approach, so we must have to use one index that will represent my base case, or you can say empty subarray. And from empty subarray, it is only possible to make sum 1. It is only possible to make sum 0. So that's why here I am having dp of 0 comma 0 as 1. Cool. Yeah, so this is the complete approach. Now let me just quickly show you the implementation. So here I am having my variable n, which is 10 power 5, the maximum number of islands that we can have initially. And then here I am having my parent array for a disjoint set union data structure. But here this time the data type of this parent array would be a pair, where one element of the pair will store the index, or you can say the leader element, and the another element will store the sum of node values in that particular set. Then here I am having this array size. Just I have used this rank by union, so that the time complexity would reduce to constant for merge and find operation. Then here I am having my find function. Then this is basically a union, or you can say the merge function, where I have used union by rank. This is the logic for union by rank, and actually this was the prerequisite, so I'm not going to explain this part. And this is the method that you have to complete. So here I will iterate from I is equals to 1 to n, and for every index I, my parent of I would be I. That is, initially all the indices are parents of itself. That's why parent of I is I itself, and then its value. Cool. And I have subtracted 1 from here because of zero-based indexing. And then I will just simply process all the queries, all the Q queries. And after processing all the Q queries, here I am having my auxiliary vector that will store the sum of each island. That will store the sum of each island. Yeah. Then I iterate from 1 to n, and if index I is a leader element, then it is stored the sum of all its node value. So then I will just simply add this value in my auxiliary vector. Cool. And after this thing, here this L is my size of auxiliary vector, and this is sum of all the elements of this auxiliary vector. And if this sum is not divisible by 2, then it is not possible. So I will just simply return 0. Otherwise, I need to check whether there exists some subset with the total value as sum divided by 2. So that's why I have divided this sum by 2. And then I have created this dp array of size +1 and +1, because we must have to consider the case for empty subarray. That's why here we have a +1. And then this is my base case, kind of, I can say, because from empty array, from empty subarray, it is not possible to make any sum other than 0. So that's why I will just simply mark all these values as 0, and then here I am having case 0 comma 0. And from all these subarrays, it is always possible to make sum 0. So that's why here I am having dp of I0 as 1 from all the subarray. From every subarray, it is always possible to select some subset with the sum 0. And that subset would be an empty subset. Empty subset has sum 0. So that's why I'm just simply marking these values as 1. Cool. And then I iterate from so then I iterate from 1 to L, and j is equals to 1 till sum. And here I'm just simply checking whether this value is less than or equals to j or not. And if it is, then this would be my answer. That is, I have both the option, inclusion and exclusion. And if this is not the case, then I just only have one option, that is exclude the element, because we only need to we have to form a sum j, and if the element value is greater than j, then it is not possible to include the element. Cool. Otherwise you would exceed the required sum. And this is my final answer, TP of L, where L is the size of this auxiliary vector, and this sum which I have already divided by 2. So yeah, this is the complete solution. And what will be the time complexity? So let's just assume the constant time for a disjoint set union data structure. So this take linear time, and this one will also takes linear time. Then it was mentioned in the problem statement that after performing all the queries, the number of distinct island would be less than or equal to 150. So that is the size of this L will be less than or equal to 150. And then here I am having this DP array, and then I'm just simply filling this DP array. So in the worst case, the time complexity would be O of 150, where 150 is the size of auxiliary array, and multiplied by the sum of entire array ARR. And actually we have divided it by 2, but let's just simply ignore this thing. And we all know that this sum is less than or equal to 10 power 5 as per the problem statement, problem constraint. Here you can see the sum of this array can only be up to 10 power 5. So yeah, this is the complete solution for all the 4 problems. Thank you so much guys for watching this video, and have a good day.